Hi students, good morning all of you. Today we are going to discuss about this system of particles and rotational motion. This is the second lecture. So last class we already learned about the basic important points about this chapter. That is what is rigid body, rotational motions, translatory motion and rolling motion and center of mass. So basic, what is the center of mass of the body? Center of mass of the body. So center of mass of the body is a point where entire mass of the body is concentrated. Entire mass of the body is a concentrated point. That point is called the center of mass. Okay, let's go here. We will discuss about the how can you find the center of mass. How can you find the center of mass in symmetrical bodies? This is a very simple concept point is there. In a center of mass in symmetrical bodies. In symmetrical bodies with uniform mass distribution. With uniform mass distribution. Uniform mass distribution. Okay, students. So how can you find what is symmetrical bodies? Simple, one of the sphere is solid sphere or hollow sphere. Solid sphere or hollow sphere. So one of the sphere is there, that is a hollow sphere or solid sphere. So another one, what is it here? Circular ring. You observe here circular ring. Circular ring. Okay, students. Next, disc. Disc. This is a circular ring. This is a disc. Okay, students. And this is symmetrical equilateral triangle. Okay, next square, rectangle and cylindrical shapes. This is a triangle. This is a square. This is a rectangle, cylindrical shape. So these are all symmetrical bodies. So generally symmetrical bodies center of mass exact at center of the sphere. Center of mass at the center of mass exact at center of the sphere. And this is also the ring also is the center of mass is at exact center of the ring. And disc also is the center of mass of the disc. Exact center of the disc, and centroid and the triangle symmetrical position, center of mass at the centroid point. Okay, and intersect of the diagonals, intersect of the point where intersect of diagonals is the center of the mass. See the symmetrical bodies. Here also is a rectangle also. Same diagonals intersect at that point. It is the center of mass of the rectangle, and along the axis of the center of the cylindrical shape point, center of mass. So these are a center of mass. You find very simply find the center of mass of symmetrical bodies. Okay, students. So next, so discrete center of mass of discrete system of particles. How can you find the center of mass discrete system of particles? Let's note here. So for example, one of the point is given here, that is two points of system along a line. How can you find the center of mass? How can you find the center of mass? Listen all of you. So this is very important point. How can you find the center of mass? Two particles of system along a line. So first point is very important. Here discrete particles. System of center of mass of discrete particles. Center of mass of discrete system of particles. Discrete system of particles. So this is very important point is here. First one is, so for two point systems, two particle system along a line. How can you find the center of mass? Okay, for example, we take the coordinates. This is x coordinate. This is x coordinate, and y coordinate is here. So this is x coordinate and then y coordinate. So take two particles along a line. First two particle masses, system of particle mass. This is another particle mass m1. This particle is x1 distance from this origin. This particle m1 is x1 distance m1 mass particle is x1 distance from this origin. Okay, students, and another particle is here. Take another particle m2 mass m2. Another particle mass is m2. This particle distance is x2 from this origin. x2 from this origin. Okay, students. And next, center of mass of the two particles assumption is take here this point. So this is x of center of mass of the two particles, x distance from this origin. Okay, students. So next is here, you observe carefully with these two particles along a line. How can you find the center of mass? Let's know this point. So this R1 and R2. What is that R1 and R2? R1 is a distance from this one particle to center of mass. R2 is a distance from M2 to center of mass. Okay, students. So both the distance between the two particles is here. What is that gap? Small d. Small. Okay, students. So here you observe carefully. The two particles we arrange along the line. The particles is from origin x1 distance. First, mass of this particles m1 and m2. This particles is we arrange here this in x coordinate from this origin. M1 particle distance is from origin is x1, and m2 particle distance from this origin is this x2. So center of mass also by assumption x. And next is here R1, R2. This is the distance from the system mass of the particle to center of mass. R2 also is the mass of the particle M1 particle to center of mass R2. So this is it. So basic information. But one important point is here. What is that? Very simple concept point is here. So center of mass of the particle system, two particle system. Center of mass of the particle system. Center of mass of particle system. Center of mass of particle system is nearer. Center of mass of the particles is nearer to the heavy mass of the body. Heavy mass of the particles. Heavy mass of the particle. Okay, students, that's mean is what is that? So heavy mass of the particle, center of mass of the system, center of mass of the particle of system, center of mass of the particle system is nearer to the heavier mass of the particle. And next, number 2 important point is here, the distance of center of mass. The distance of center of mass of any particles, any particle, mass of the particle, any particle, distance of center of mass, distance of center of mass, distance of center of mass from any particle, is inversely proportional to the mass of the particle, is inversely proportional to the mass of the particle, mass of the particle. So this very important point, distance of center of mass from any particle is inversely proportional to the mass of the particle. But how do you write this here? So this is very important. Distance of center of mass from any particle R is inversely proportional to the mass of the particle 1 by m. This is a very important point. Is remember this. The second condition is distance of center of mass from any particle is inversely proportional to the mass of the particle. R is proportional to 1 by m. Okay, students. From this diagram, you observe carefully. So from this formula, R is proportional to 1 by m. So how can you write this? R1 by R2 is equal to m2 by m1. From this formula. So R is proportional to, let's know here. R is proportional to 1 by m. This is one of the points. By distance is inversely proportional to the mass. Distance of center of mass, any particle is inversely proportional to the mass of the particle. We how we write R1 by R2 is equal to m2 by m1. Okay, students. And next, m1 r1 is equal to, how can I write this in cross multiplication? How can I write m1 r1 is equal to m2 r2. Okay, this is one of the equation. Remember this. But how can you find this r1? So r1 value, how can you get this r1? Distance of center of mass, when you find this r1, listen carefully, when you find this r1, so distance of center of mass and object distance of particle, distance of center of mass, distance of particle. So distance of center of mass xm r1 is equal to, how can you write this? When you find this r1, the distance of center of mass, what is that here? xm minus, when we remove this distance of the particle x1. Okay, students. And next, how can you find this r2 is there? So distance of the particle 2. When you find this r2, distance of the particle, second particle x2 minus, remove this the distance of center of mass, x2 minus x. Okay, students, this r1, r2 value substitute in this equation. Okay, then we get this answer is there. So next is here. So when you remove these points, this is right. So listen here. What is the equation given m1? What is the r1? What is r1 is here? So distance center of mass xcm minus x1. is equal to m2. R2 is meaning x2 minus x center of mass. Okay, students. So when multiply with both them, m1 x center of mass minus m1 x1 is equal to m2 x2 minus mx center of mass. m2 center of mass. So when you observe carefully, m1 x center of mass, m minus m1 comes to this side plus m2 x center of mass, it is equal to m2 x2 minus m1 x1 goes to the right side, m1 x1 plus m1 x1. Then how do you write here? What is the common x center of mass? X center of this common is here. So x center of mass is common. So what is the remaining? m1 plus m2. m1 plus m2 is equal to m1 x1 plus m2 x2. Okay, students. When you find the center of mass of the resistance, x center of mass is equal to m1 x1 plus m2 x2 by m1 plus m2. This is a very important center of mass from this origin. Along the two particles, between the two particle system. In two particle systems, center of mass m1 x1 plus m2 x2 by m1 plus m2. This is center of mass formula, very important formula.